You guys have your packets? Who doesn't have one? Victoria doesn't have one. Who else doesn't have one? Gabby doesn't have one. Kyle, you don't have one? Did you come in late, Kyle? I feel like you sneak into class sometimes, Kyle. You just sneak in unnoticed. Anybody else need a packet? Okay, let's make sure our phones are away, please. All right. So, what's the deal? I'm going to go through this packet. Everything in this packet is what's on your test. There are other types of questions, certainly, that I'm not covering in this packet / in this review that can potentially be on your test. Okay? Everything that's fair game is everything that you've been assigned in your homework. Okay? Nothing more and nothing less. So, what I'm going to be covering today is the basics. And there's enough of the basics to just take the rest of the time. I will also provide time for questions at the end. So the first thing that we're going to cover is set theory. Okay? And that was the beginning of chapter 22. It's lesson 22.1. Okay, in set theory you have certain sets. So for instance, set A, I said, is odd numbers less than 10. Okay, so set A then is 1, 3, 5, 7, and 9. And then I said set B was prime numbers less than 10. So B is 2, 3, 5, and 7. Does that make sense? Okay, now my sample space is all my numbers, my natural numbers that are less than 10. So S is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? Now I go through the different notations. So A intersection B is all the things that are in both A and B. So that's the numbers that are included in both sets. Well, that's only 3, 5, and 7. Okay? Then A union B, which is the regular U, means everything, if it's in A or in B, it's included in this. So that's 1, 2, 3, 5, 7, and 9. Okay? Now, the one thing I neglected to put, and you might want to put this in your notes, like beside the, like right to the right of this, is A complement. I should have put A complement, and I forgot to put that. So A complement is everything that's not in A. So that's all the ones that are not odd, or in other words, the even numbers. So that's 2, 4, 6, and 8 are an A complement. So you might want to write that. That's the one thing, at least that I can realize right now, that I didn't put in the packet. So make sure you write that, because that will definitely be on the test. Okay, so to repeat, A complement is everything that's not in A, but in my sample space. So since A is odd numbers, A complement is even numbers. Then I give you two new sets, and it's set C, which I say is 1, 2, and 3, and then set D, which is 2, 3, and 5. And then I ask, is C, I'm not going to write this down because it's just on there, is C a subset of A? Or I will write it down. Is C, set C, a subset of A? That's what this sideways U means. C a subset of A? And on there I put no, but why is C not a subset of A? Who can tell me why C is not a subset of A? Well, C has 1, 2, and 3, but is 2 in set A? No, the 2 isn't in set A, so therefore, in order for it to be a subset, everything in C has to also be in A. That's what makes it a subset. So C is a subset of A? No. Then I say, is D a subset of B? And D has 2, 3, and 5. Well, 2, 3, and 5 are in B, so this is yes, because everything in D is also in B. Then I say, okay, what's the probability of A? Which in other words is the probability that you get an odd number. Well, that's where this whole NA over NS thing comes from, was from set theory. That's where we first were introduced to NA over NS. Well, number of elements in A is 1, 2, 3, 4, 5. So it's 5 over number of elements in my sample space is clearly 9. So the probability of A is 5 over 9. Probability of B is number of elements in B over the number of elements in my sample space S. Number of elements in B is 4 over number of elements in my sample space is 9. So that's my probability. Does that make sense? Any questions on that? So that's everything on set theory. Okay. Obviously, there can be more than this. There's all sorts of questions in your homework that are fair game, but this is the basics. With this understanding, you're able to understand the rest. Okay. Actually, there's this one last bit down at the bottom here. It says, what is the probability that you'll roll a prime number? So, for instance, if I have a 6-sided die, what's the probability I roll a prime number? That could be just a word question that I ask you. I won't tell you it's set theory. I won't tell you anything. I'll just say you have a 6-sided die. What's the probability you roll a prime number? Well, in this case, you'll have to say, well, set A is what I'm interested in, and that's the prime numbers. That's 2, 3, and 5. And set S is my sample space. That's all the numbers I could roll, which is 1, 2, 3, 4, 5, and 6. Sorry. 1, 2, 3, 4, 5, and 6. Oh, baby giraffe. I wonder what a baby giraffe is called. 1, 2, 3, 4, 5, and 6. Okay, so the probability of rolling a prime number is PA, which is NA over NS. Now, guys, I'm not trying to trick you. I'm not going to put set theory questions with permutations and combinations. I'm not going to mix them all up, okay? Because it's already confusing enough. I'm going to put all the set theory questions together. You just have to know how to do it. So I'm not trying to trick you to try and figure out. I'm not trying to do that. I'm just trying to make sure you understand how to do the questions when you kind of understand what question you're being asked, okay? So if you notice that a question on probability is in a set theory section, like in the beginning of the test, chances are you're just doing the simple probability and you just got to write down your sets. All right, so that's just 3 over 6 or 1/2, which is equal to 0.5. Okay, you don't always have to get the decimal answer for probability, but I prefer it. Any questions? Okay, so moving forward, we go on to permutations. So in permutations, order matters. Okay, order matters in permutations. The question is, how many ways? Now, the simplest type of permutation problems are what you see at the top. For instance, how many ways to order n objects? The answer to that is just n factorial. An example of that is, say I've got 10 songs in a playlist. How many orders can they be put in? Just 10 factorial, which is 3,628,800. Okay? So if you just asked a simple question where there's just, generally speaking, there's just one number, right? It's not going to have a bunch of numbers. It's just going to say, okay, you've got 10 songs in a playlist. How many ways can they be ordered? You know it's not NPR because there's only one number. How could you figure out N and R? It's just one thing, so you're going to be doing n factorial. Now another example of this would be, how many ways can you stand 6 students in a row? And again, that's just the number factorial. So it's 6 factorial, which is 720. So that's the simplest form of permutations questions. It's just the number factorial. Now, next after that is permutations with repetition. Okay? And in permutations with repetition, the formula is n factorial over a factorial, b factorial, ... Okay? Now, n is the number of letters, the number of objects, whatever it is, and a and b are the number of times they repeat. Okay? So, for instance, the word Mississippi. I'm not going to do that example. I think I've already done it, but I'll just do Mr. Manier because I actually want to cover one other example that I just thought of. Mr. Manier, okay, how many letters? 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 factorial over A is 2. 2 times M is repeated. R is repeated twice. And E is repeated twice. So I get 5,040. Different ways that you can arrange those letters. Does that make sense? Now a different kind of example, and you might want to take this down in your notes because I didn't put this on there, is if you've got like 4 boys and 5 girls. And I say, how many different boy and girl arrangements are there? I don't care if the boys are in different orders or the girls, I'm just thinking boy-girl arrangements. Well, in this case, it would be 9 factorial, because there's 9 people in total, over 4 factorial, 5 factorial. And if I do that in my calculator, I'd get 126. Does that make sense? So it's not just letters, it's anything where there's repetition. And again, these are just basic problems. There can be all sorts of different ones. Everything on your homework is fair game. Any questions on this? Okay. Next. Now, this is the most common type of permutation problem, is when you're picking from n objects r at a time. So when you're picking n objects r at a time. And generally speaking, I've written n in blue and r I've written in red. So n objects r at a time. Then we get npr equals n factorial over n minus r factorial. Now, you're going to be responsible for answering a multiple choice question of what this formula is. Okay? So you have to be able to remember it and recognize it. This is not the same. That's not the same. This is not correct. Okay? This is not the same. Okay? That's not correct. Or any other kind of strange formulation of that. That is the way you write it. There's no other way. Does that make sense? Okay, you will be responsible for picking that out. It's just a multiple choice question. I don't care if you look at it right before you look at the test and then just find it and circle it. I don't care. Just make sure you show me that you can remember it in that moment, please. All right? Next. How do you use this? Well, generally speaking, we are not going to be using that formula just because it's hard enough to do all the things that I'm asking you to do on this test, so I'm not making you do this formula a whole bunch of times. Okay? What I am going to be asking you to do is just be able to use your calculator. So if you haven't used your calculator for this and you've just always used your phone, now is the time over this weekend to make sure you can do this on a calculator. Okay? So an example would be 8 people in a race. How many ways can they finish first, second, and third? Okay, so the primary determination here is what's n and what's r. So what's n? What's n? 8. Good, thank you. And then r is 3. Good job. So I get 8p3. Plug it into my calculator. I get 336. Done. Okay? Then the next example I say, how many 4-digit PIN numbers can be made from digits 0 through 9? All right? And it's key if no numbers are repeated, because if there is repetition, the answer would change. So what's n? It's 10. It's right there. Right? N is 10, r is 4. I'm picking from 10 numbers. I'm picking 4 at a time, so it's 10p4, which is 5,040. Again, you just plug that in your calculator and you're done. Any questions on that? Okay. Remember, guys, this is your last test. There's a reason why I'm giving you this packet, so I really want you to be able to study and study well. so that you can go into the final prepared. It's one of the hardest things that I can do when I'm like grading senior final exams, and I'm like trying desperately to find extra points so I can get you from like a 79 to an 80, and I'm looking for the final exam and I'm like, I can't. That's rough, right? I don't want to do that. I really don't like being in that position, but that time for that to not happen is now. Does that make sense? And then in studying for the final. Because there have been times where I'm like, there have been times where I could do it, where I'm like looking through the final, like they deserve an extra point here and maybe there, and I can kind of like move it up depending upon what I see. But there are times where I can't. You know what I mean? So it's just like, don't put me in that position. Don't put yourself in that position. Just study, and now's the last time you have that chance to really do this. And you guys are seniors, so you might as well like kick it into high gear right at the end, or most of you at least. Yes, ma'am. No, I was going to do a project, but it just didn't work out time-wise. I'm sorry. I wanted to do a project on volume, but Khan Academy and things didn't work. What was that? This weekend? I understand. I just wasn't able to do it. I wasn't able to work it out time-wise. Okay, so now I work into permutations and probability. Permutations and probability. Now, we combine everything from permutations that we just learned with probability that we learned in set theory. Okay, so for instance, first example is 12 people in a race. Four from the U.S. Okay, what's the probability that the U.S. will win first, second, and third? Okay, well, probability, the first thing I write down is PA equals NA over NS. Then I have to determine, remember, NA is what I'm interested in. P is what I'm interested in, and NS is all the possibilities. Okay, so NS in this case, what's N? What's N? 12, good. I have 12 total people to choose from, and how many am I choosing? 3, good. Choosing 3 at a time for first, second, and third place. So it's 12p3 is 1,320. Now, NA is what I'm interested in. Who am I interested in winning the race? US. So what's N? 4. There's 4 of them. Okay. R is still 3 because I'm still interested in first, second, and third. So 4p3 equals 24. So probability A equals 24 over 1,320, which is 0.018 repeating. Okay. Any questions on that? All right, good. I gotta open this and close it up again. Right, just go back to it. Now, next. What? Epic. Sorry, they just said that that's free. I've been using the trial version forever, but the full version is epic. There's so many cool things to do with it. Sorry, that was a moment. I hope you appreciate it. So choosing 5 letters from the alphabet, and I tell you that there are 26 letters in the alphabet, though we should all know that. I will tell you, there is nothing on this test where you'll have to guess how many numbers or something like that. You will be told explicitly. So you're choosing 5 letters from the alphabet. Okay, what's the probability you choose the letters A, B, C, D, or E in any order? Okay, well, again, it's PA equals NA over NS. All right, Now, NS is all my possibilities. So what's N in this case? 26. Good. 26 letters to choose from. And R is 5. Good. So it's 26P5, which is 7,893,600. Okay. Then NA is what I'm interested in. So which letters am I interested in? A, B, C, D, and E. So N is 5. Good. You guys see the pattern here? It's just the same kind of deal over and over. Okay. So 5P5 equals 120. Probability of A occurring equals 120 over 7,893,600. 0.0000152. Done. Okay? All right. Good. Let's move on to the next question. Any questions at all? No? You guys feeling good? Olivia's taking copious notes on my lecture. Oh, if only I just love you guys so much. Look, we've got 3 people just sleeping. 4 people. Nice. You know what? I'll just go to sleep too. I'll see you guys again. I'm not mad. I'm just kidding. I'm just joking. It's so funny though, right? It's like, why are you guys so tired? Right?
And when kids who are asleep wake up, they start clapping.
Yeah, we've done that. I've done that.
Yeah.
Or we just all go.
That would be epic. Imagine. Isaac's not too fast.
Jacob's
He just loves. Caitlin, she's just resting. If we just got up and left.
Can we?
No, of course not. But that would be funny. That would be good. It'd be a good like senior prank, right?
Did he do that? Did he do that?
Okay, so combinations. Let's get through this packet. We only have 2 more pages. Combinations, order doesn't matter. Okay, I will repeat, order doesn't matter in combinations. Make sure you remember that. I may ask you a question. In which one of these does order matter? Permutations or combinations? You'll have to tell me. Permutations order matters. Combinations order doesn't matter. Yeah, so you may have to be able to do that. The formula for combinations NCR is n factorial over r factorial times n minus r. Okay? I'm definitely going to put in on the multiple choice questions things that look like that, right? So it's not going to just be obvious. You have to know which one the actual formula is. Okay? So order doesn't matter. There are 8 kittens. How many different groups of 3 kittens can you choose? So 8 kittens. I'm talking about groups of 3. So order clearly doesn't matter there. What's n?
8.
N is 8. Good. What's r?
3.
Yeah. If I say a group, you know that I'm not talking about an order, right? Very good. So it's 8. Thank you, Hallie. It's 8C3, which is 56. Clear? All right. There are 20 students in a class. How many different groups of 5 students? So again, the word group shows up. It won't always show up, but if it does, you can be pretty sure that it's...
So pretty much any word that kind of means group.
Yeah, kind of. But if I say, like, I dip my spoon in my bowl of alphabet soup and I pull it up, how many different types of spoonfuls can I pick up? I don't know how I'd word it, but you understand? Order doesn't matter. It's implied that the order doesn't matter, right? Does that make sense?
Yeah.
So it's not just the word group. It's actually understanding that the order doesn't matter in that case. So N is 20, R is 5, so we got 20 C5, which equals 15,504. Okay? Any questions on this at all? All right. Now we combine combinations with probability. All right? And there are 3 basic types of combination questions that I can ask you with probability. So I will go through all 3 of those now, and then we will be done. And we should probably have like 5-10 minutes of free time. Maybe we can finish the Kahoot. I don't know. There are 4 men and 6 women in a group. 4 men and 6 women in a group. You choose 3. What's the probability that it's all men? So it's probability, so you're thinking PA equals NA over NS. All right? So you have to determine NS first. What's N in this case? Somebody tell me. 10. Good job. N is 10. And R is 3. Good job. R is 3. So we have 10C3, which is 120. Now, for NA, what am I interested in? All men, right? So N is 4. Good. N is equal to 4, and R is equal to 3 still again. So I'm still picking 3 of them. So it's 4C3, which is 4. Probability of A is 4 over 120, which is 0.0333, and just 3 is repeating. Cool? All right. So that's kind of the simplest one with combinations and probability. Then after that, we get into the coin flipping thing. All right? So you flip a coin 5 times. Flip coin 5 times. You're interested in landing on heads. What's the probability that it lands on heads 3 times? So again, you start with PA equals NA over NS. Then you determine NS and NA. So NS, you flip the coin 5 times. Yes? Very good. Good job. 2 to the 5th power. Okay, if you flip it 6 times, 2 to the 6th. 18 times, 2 to the 18. So 2 to the 5th equals 32. NA, in this case, N is the number of times I flip my coin, which is 5. R is the number of heads I'm interested in, which is 3. So it's 5C3, which is 10. So the probability of that occurring is 10 over 32, which is 0.3125. Bam. Okay? Any questions on that? All right, almost there. Last one. Last question to do. Let's take a look. Now, same deal. You flip a coin, except you flip a coin 7 times. What's the probability that you get at least 5 heads? And I underline that because at least 5 means 5, 6, and 7. Those are all possibilities I'm interested in. And in this case, remember I have to add up the possibilities for all of those. So I start with NS. So remember PA equals NA over NS. NS, I flip a coin 7 times, so it's 2 to the what class? 7. Very good. 2 to the 7 is 128. Ms. Fink, good job. Appreciate it. All right. NA. Now, with NA, I'm interested in 5, 6, and 7. So I've got to check out all those different possibilities. So I'll write it down like this. 5 heads, 6 heads, and 7 heads. I'm interested in all of those. So for all of them, I'm still flipping the same amount of time. So N is always 7. But then R just matches the number of heads. So R is 5, R is 6, and R is 7. We then get 7C5, 7C6, 7C7. 7C5 is 21, 7C6 is 7, 7C7 is 1. Now, once I have all that, I just add them up. Simple as that. 21 plus 7 plus 1 equals 29. And the probability of A equals 29 over 128, which is 0.227. And I'm done. Any questions?
So you ever give us
Rolling a dice?
You know how a coin only has like two sides? Will you ever give us like 1, 2?
No. I'm not going to do that on this test because it becomes very confusing, actually. Yeah. Any questions at all other than that? Okay. Good job, class. Your test is on Monday. It'll take the whole hour. Thank you very much.